Hi everyone, welcome to another Science North virtual star party. I'm your host for the evening. My name is Olathe. I'm the staff scientist for Space Place and the planetarium. And of course, I am joined by the lovely Lucy, who is the science communicator for the planetarium.
Hello everyone.
We're super excited you're here tonight, and we're excited to be talking about a supermoon. But before we get started, I would like to acknowledge that we are on the traditional and ancestral lands of the Atikameksheng, Anishinaabeg, and Wahnapitae First Nation. And we would also like to acknowledge the Métis Nation's contribution culturally and economically to this area. We sit on the Robertson-Huron Treaty area, and we are all treaty people. So it's important for us to be thinking about the treaty area that we are an active part of, and I encourage you to take a moment to think about the treaty area you are in right now. All right, so onto the supermoon. The definition of a supermoon is one that is, it can be a new moon or it can be a full moon. It just needs to be closely coinciding with perigee, or the moon's closest approach to Earth, in its monthly orbit around the Earth. Now, this idea of a supermoon was actually coined by an astrologer, so not an astronomer. And sometimes when I'm talking to people, I hear that mix up. So an astronomer is studying the night sky. An astrologer is someone who's sort of taking what's happening in the night sky and applying it to people's lives. And actually, Sir Isaac Newton was quoted roughly as saying that astrology was God's way of giving astronomers a way to make a living. Because of course we find things more interesting when they really relate quite directly to ourselves, right? So this idea of the supermoon was popularized by an astrologer. His name's Richard Knoll, and that was just in 1979, so pretty recent. And by his definition, it's when the moon is within 90% of its closest approach to Earth. So in this image, you can see a full moon at apogee, which is sort of the furthest that it would be from Earth. And then you can also see that is laid onto a supermoon, so one that's at perigee. So when the moon's at apogee, it gets called a micromoon. So it's not a big difference. And as a fun trick, if you wanted to share this with friends, you can hold up a nickel and a quarter, you overlap them, and you get about the apparent difference. So that's kind of fun. Oh, and I am presenting now. I'm just going to be doing this quick presentation, and then we're definitely going to be answering your questions. So please, if you have questions, put them in the comments. We're going to get to them throughout today's live stream. We are going to be answering lots of questions. Okay, so coming back to the science behind the moon, you've got, you can say it's not really a big deal. It's just about this much. But, what is it really when we get into looking at the orbits and that sort of thing? So I've got a slide that shows the difference between apogee and perigee. So those are our science terms of the day. So we can bring that up. And this difference, it's about 14%. Supermoon is about 14% larger than sort of your average moon. But you can still cover it with your pinky finger. So I don't know if you guys have heard of the moon illusion. Has anyone heard of that? Moon illusion? Oh, I see Dokis First Nation. Awesome. Welcome to have you here. Oh, and Linda's here. Yay! So Linda P is from the Rask Sudbury Center, and she will also be helping answer questions in the chat, which is awesome. Okay, so the moon illusion. So the moon illusion, there's a couple parts to it. You might have heard of it as when the moon is on the horizon, it looks really, really big, right? And it's not actually any bigger. It's just an illusion. Once it rises up in the sky, it's the same size, but it looks smaller. And a cool trick you can use to show people the moon illusion is covering the moon with your pinky finger. And even if you can't do this when it's on the horizon, when it's higher up, the moon is actually, it appears bigger than it is to us. So if you ask a friend like, hey, do you think I can cover that moon with my pinky finger? They'll most likely say no, you know, but I'd like you guys to try this tonight. If you hold your pinky finger at arm's length and you hold it, you know, in front of the moon, you'll actually be able to cover the moon with your pinky finger. And that's true whether it's a supermoon or a micromoon. Okay. Renata, if you could pull up the apogee-perigee slide. Yes, excellent, thank you. Okay, so apogee is the moon's, furthest, did I say it backwards? I think I said it backwards. This is why we have this slide. Okay, so apogee is the moon's furthest distance from the Earth, and perigee is its closest distance. And we often see this distance exaggerated in diagrams like this, just to get the point across. So that 90% definition from Mr. Knoll means that a supermoon is any moon that is within about 360,000 kilometers of our planet, as measured from the center of the moon to the center of the Earth. Oh, Ottawa and Edmonton, awesome. If anyone has any cool like mnemonics to remember the difference between apogee and perigee, I would love to see those in the chat, because that's it's one of the things that I'm always like, okay, apogee, opposed, I don't know, perigee, like, so share that. If you have a cool one, share it. All right, okay, so what does this actually mean? We know that this is an exaggeration. So what does the actual difference look like to scale? So this is an image from timeanddate.com. They are one of my go-to websites. I absolutely love them for all things astronomical. When is there a lunar eclipse? When is there a solar eclipse? They're an incredible website, and you can get information for your particular location. Hopefully we'll be doing a live stream with them on June 10th of the solar eclipse. Excited for that. Anyway, timeanddate.com, yes. So here is to scale kind of different. So the furthest the moon is getting from the Earth is 405,000 kilometers. So this isn't a huge difference, right? And what we see, if we kind of zoom out and look at this here. Oh, sorry. This diagram is showing this sort of, to scale, but even here, the distances are so huge, and the moon and the Earth are so small that you can see the actual moon-Earth distance to scale is shown there at the bottom. And for the purposes of the diagram, even that's been compressed a bit. But you can see it's not really a big difference. Now, because of this 90% approach qualification, to be a supermoon, we actually get a supermoon season. There's not just one supermoon. So April 27th, we're going to, on Tuesday, we'll have the moon will look full on April 26th, but the true supermoon is April 27th. That's when it's the fullest. And then we're going to get another one on May 26th, which is like even, a little bit, well, it's a little bit further away. And then we'll have another one on June 24th, but they'll all be considered supermoons. So you'll get more opportunities to sort of weave your supermoon knowledge into the conversation and show people this sort of fun little demo, and hopefully even get out and be looking at the moon and get to use your moon illusion. That'll be a lot of fun. Okay. Now, one last thing I'll share with you quickly is just that this supermoon season that we don't get it at the same time every year. And that's because this elliptical orbit, it is slightly elliptical. I mean, it looks circular in this diagram, but it is a slightly elliptical orbit. It has a precession. So when you're seeing that closest approach happening at a full moon, changes from year to year. And it actually changes by about a month and 18 days. So next year in 2022, we're going to see this season shifted a bit. Okay, now in terms of when to see the moon, where to see the moon in the night sky, I'm going to pass that over to Lucy and Stellarium.
Hello everyone. So I have Stellarium up. This one's a web-based program. So if you go to stellarium-web.org, you'll be able to find this really neat app. Well, I'll just kind of move this out of the way. Now we're looking towards the north, and we can see a lot of really neat things in here. Right now, well, in the program, it's showing us that there's some satellites going by, some starlinks. However, if we want to take a look at the moon, we have to look a bit further towards the south. So spinning this around here, we've got our lovely moon. Now, the full moon coming up is on the 26th. So it's just in a few days. To change the date on this program, we just have to go to the bottom right-hand side and going up few days, 26. There we go. We could see the full moon right here in the southeast. We'll get to see it when the sun's a little bit after the sun sets. If we go outside right when the sun sets, we'll get to see the moon, but very little stars. Let's see if we can. There we go. So if we zoom through time, fast forward through time, we can see that as it gets darker out, we'll see more and more stars, and we'll get to see a nice, lovely full moon coming up. And well, if we want to take a look at what tonight looks like, we'll just have to go back to tonight. And let's go just a little bit later if the program lets me. Sometimes it lags just a little bit. So I might not let me fast forward right now. That's okay. So tonight at around 9:30, we'll get to see almost full moon right up here. If we click on it, it pops up some extra information on the top left-hand side. And we can zoom on in right up to the moon. So if you have a pair of binoculars or a telescope, you'll get to see the moon really well. I don't always suggest to take a look at the moon when it's full. It's very bright and really hard on the eye. So if you look through it through a telescope, there are filters that you can get to diminish the amount of light, so that way you don't uh, it's not too bright for you. But if you're looking through a telescope, you won't see the whole moon. Oftentimes, you zoom in really, really far in, so you'll only see part of the moon. A really good time to look at the moon through binoculars or telescope is at the corner moon. So you can see the shadows in the craters on the moon really, really well, which is really beautiful to see.
Lucy, I
I,
do have a question here.
I just saw it, yes.
Yes, okay. Do you want to take that one?
Yeah, sure. So, are we always seeing the same side of the moon? In fact, we are seeing the same side of the moon. So, as the moon goes around the Earth, it's actually spinning on itself so slowly that the same side is always facing us. So we always see what we people call, for example, the man on the moon. We've got this kind of like look of the Mars. So we've got the darker gray portion here versus the lighter portion. So we're always looking towards the same side of the moon. But that side of the moon isn't always the dark side of the moon, since the moon goes around the Earth. Depending where it's at, we'll get to see either the full moon, or if it's on the other side, it's the other side of the moon that's getting the sunlight, and we see a new moon. So for sure, if you guys have any more questions, put them up in the chat. We're more than willing to answer any of your questions. So I also wanted to show everyone a little bit of stargazing, a bit of star hopping. To start off, let's start towards the north. So if anyone was around during our virtual star party last week, you might remember this. So looking towards the north, fairly high up. So zooming out, we can see that if we look right above our heads, which would be around the middle here, that would be the zenith right above your head. And not too far, we have a grouping of bright stars. So right here, we've got these stars that make up kind of like a pot area and a handle. Many people call this the Big Dipper. But the Big Dipper is an asterism. It's part of a constellation. So if we take a look over here, these stars aren't as bright, but we have a triangle for a head, stars over here for the front paws, back paws. So I have down here little buttons that I can press to bring up the lines and the name of the constellation. So we have Ursa Major, which is the big bear, and we have here Stellarium's picture for it, which somehow it's a bear with a really, really long tail. Now, from here, we can do a bit of star hopping. We can take the two stars right at the edge of the pot of the Big Dipper, taking away the lines and the art, just so that we can see what it would look like without. If we go outside, we'll see these two stars right at the edge of the pot, and we'll follow this imaginary line it makes outwards. We call the two stars from the Big Dipper over here pointer stars because it points to this really neat star known as Polaris, or the North Star. It's right above the North Pole, so as the Earth spins on itself, it's a star that doesn't move no matter what time of day it is, no matter what time of night. If we can, well, you won't be able to see it during the day, but no matter what kind of night or what time of year it would be, if we can see the North Star, we know for sure that we're facing north. And it happens to be part of its own constellation that doesn't have as many bright stars. There's these two stars here that aren't too bad if you're far from any big towns and cities where there's a lot of light pollution. So, in other words, if you're kind of in the middle of nowhere, you'll get to see these two stars here, and maybe you'll get to see these other stars that make up a handle and a pot. So we would have the Little Dipper, but also known as Ursa Minor, the little bear, another bear with a really big tail. Before we keep going, Olathe, do we have any more questions?
Yeah, we should do. We do have some about Orion. Someone is asking to see Orion's belt, and then we have another person asking if Orion is still up. So we think of Orion as a winter constellation, but is it still possible to see Orion in the night sky tonight? And if so, could you show us his belt?
Of course. We can just see him still. It's getting pretty low in the horizon. So yes, we know him as a winter constellation because we can see Orion in the night sky after the sunset throughout the whole winter season. But now that we are in spring, it's actually very low towards the western horizon. We could just still make up Orion if there's not a lot of buildings in the way. So looking towards the west, we can see these bright stars here. So we've got the three stars in a line that does make what people know as Orion's belt, but that's just part of the constellation. We've got some stars up here that make up his shoulders. Down here would be legs and knees. There's even some stars up here for his head and for his arms on either side. So Orion is known as the hunter, and we have him up in the night sky just over the western horizon at this point.
Okay, while we're on constellations,
Yes.
my niece Tessa just came on. Hey, Tessa. And she's wondering if we can see Gemini in the night sky right now. And then we have a bunch of moon questions. So we'll get back to the moon after this one.
Perfect. Yes. So
Wait,
Gemini is a
wait.
really neat one. And
Can we
Yeah.
zoom in on the Orion Nebula while we're on Orion?
Of course.
Sorry, and then Gemini.
Okay, yeah. This is a really neat program. We can just do some searches. We can find all sorts of things here. So if
Yeah.
we zoom on in, we
This
can
is a request
find
from Jaden here.
nice. So we can find the Orion Nebula right here. So the program does have deep sky objects on here too.
Yeah. Now on my screen that's looking a little washed out, there's definitely a lot more detail in there when you're looking at it through a telescope or at some of the, well, maybe not a telescope, but definitely some of the Hubble Space Telescope images are just absolutely beautiful. If you're interested in seeing nebula, they're gorgeous.
Exactly. So yeah, or the Orion Nebula is found right in this cluster here underneath his belt. And Gemini is a really neat constellation to find from Orion. So because Orion has a lot of bright stars, it's a nice one to start off and star hop from. So if we take the star in his foot called Rigel and follow the bright star in his shoulder called Betelgeuse, we can go further up. I'll just zoom on out. And we can find these two stars here. that's part of a constellation. So the two stars actually represents the head of Gemini, the twins. If we just look at their stick figure, one of them has really long legs and the other one has longer arms, but they're meant to be twins. If we take a look at their art, one star is in fact called Castor and the other one's Pollux for the two bright stars for their heads. So those are also the names of the two twins.
Very
All
nice.
right.
Okay, so we have a question here. How many days of the year do you see the dark side of the moon? So the thing, the dark side of the moon isn't actually dark, right? Like as we were talking about, like it's just the side of the moon that we don't see. So we're always seeing the same side of the moon. So we don't get to see the dark side of the moon. But when it's a new moon for us, the dark side of the moon is lit up by the sun. So yeah, I hope that clears that up for you.
Yeah, I don't think I was super clear when I was talking about that. So thank
Yeah,
you.
and it's just because of sort of the way the moon, the sort of the gravitational relationship between the Earth and moon. So the moon is kind of held. So the moon is orbiting like it is sort of, sorry, it's as it's orbiting Earth, it is rotating, but it's rotating at a rate that keeps that one side that we see always facing towards Earth. So its sort of day is about the length of the month. So we're always seeing that same side because it's just sort of slowly rotating as it orbits around Earth. It's kind of neat. So it's sort of locked in. I believe it's called tidally locked. And then we had another question about the moon. How old is the moon and did it form at the same time as the Earth? So this is actually a question we got for our Insta story yesterday. So the moon is about the same age as the Earth. I think it's 4.53 billion years old, and it formed when there was proto-Earth, and there was a planet about the size of Mars called Theia that impacted Earth and sort of fused with Earth, but knocked off a chunk. And that chunk that got knocked off was caught in Earth's gravitational well, and that became our moon. So they're about the same age. Okay.
So neat.
Yeah, it is. Okay, and I think, oh, and our other question was, does the night sky look the same from everywhere in the world? And I'll start off with a moon fun fact, which is that the whole world does see a full moon at the same time, right? If you think that about how that moon is behind the Earth compared to the sun, so the sunlight is shining on it, and that's happening for the whole world at the same time. But the stars, on the other hand, Lucy, I'll let you take this one.
Yes, so depending where you are on the Earth, you'll see different stars. And it has to do with pretty much how far north or south you are. So everyone that's on the same latitude would see the same stars. But if you go further north, you'll get to see a bit further up towards the north. So let's, in fact, see if my program will let me change location because it's been a little slow. I'm a little uncertain how this will happen. So if we zoom on out, let's go very far north just to see a nice big difference. So we see how low Orion's at and Mars from my view. Let's move my little location up north and use this location. Okay, already we can see that things are a bit different. The sun's still up. So let's fast forward a bit in time. There we go. I went so far north that the sun's still up. All right. So we can see that, well, the sun's very bright. We've gone so far north that we're not quite in the summertime yet, so we don't get to see a midnight sun, but it's close. If I take away the atmosphere, though, we can see lots. The moon is down here. Mars is way over here. So yeah, we can't see Orion anymore. We're actually looking much further north. I don't know if you remember, but when we were looking north, the North Star was around here, but now it's much further up. If we go right to the North Pole, the North Star would be right above your heads.
That is so cool.
Yes. Now let's go in this below the equator, just for the fun of it. Use this
Hi,
location.
Juanita.
So, atmosphere. You know what? We can see more if we take away the atmosphere. So right now we get to see different stars. Looking north, well, we can just make up the handle of the Big Dipper. The rest of the Big Dipper is down over here, with the North Star probably way over here. We can probably see, looking further this way.
I've got a question here,
Yeah.
actually from my nephew, Kevin. He's asking, why are stars shaped like circles? And this is a really cool question, and you know, planets too, right? It seems like when you look out into space, you kind of get a lot of circles and maybe disks, right? Galaxies and solar systems are disks, and then we get these circles of stars. And of course, the nebula, the clouds of gas and dust. But because of gravity, as matter comes together, once it gets to a certain size, like asteroids and things like that are kind of irregularly shaped. But once we get to a certain size, usually that material, as it's coming together, it forms a sphere, just because every bit of that material wants to get to the center because of gravity. And so you get a nice spherical shape. And with planets, of course, it's happening because also there's impacts. And so rocky planets like the Earth start out as balls of lava, and they're kind of malleable and they can form that circle. And then stars are big balls of gas, right? Mostly hydrogen gas. And so they're just a big ball of gas and they swirl together, and it's just the best shape for everything trying to get right to the center. So that's why stars are circles. They're big spheres.
Big sphere. Like planets. Gravity's pulling on everything on every side to pull towards the center.
Yes.
So I actually changed the time on this Stellarium so that I could compare to what we were looking at. So we're back at around 9:50. And we can see that the Big Dipper is really low, North Star, below the horizon. Orion, he's actually sideways. And we can see some constellations down here that we can't see up here in Sudbury. So depending where you're located, you'll get to see different constellations. If you're in the southern hemisphere, you'll get to see some of the southern hemisphere constellations that we do not get to see up here. All right, let's head back home.
And maybe while we're heading back home, I'll answer another question here. So why does the moon orbit? So you can think of gravity as a warping of space-time. So
it's very easy to think about.
Yeah. We think of space-time as sort of one thing, and you can even think of it as like a fabric, right? So the fabric of space-time. Actually, just working on it. I don't have any heavy things yet to put on it, but let's imagine that this is the fabric of space-time. And if you put something heavy in the fabric of space-time, it bends it. So see, I don't know if you kind of see this bend here, right? And we call that bending around whatever's in there. So imagine it's the Earth. We call that bend a gravity well. So it is happening in 3 dimensions, but it's easiest to sort of picture it in this sort of 2-dimensional state. So you've got this indent now in space and space-time. And so when something approaches that indent, if it's moving slowly, it's going to sort of roll right down and it's going to collide with Earth. So think of a meteor hitting the planet. But if it's moving pretty fast, it can go into an orbit, which means it's still moving through space-time in what, like, relative to itself is a straight line. But because space-time is now bent around this object, it ends up going in circles. So that's why the moon orbits the Earth. It's caught in Earth's gravity well. If it was going faster, it would escape and it would fly off into space. If it was going slower, it would crash into the Earth, but it's going just at a good speed to keep traveling around in what kind of seems like a straight line, but it's bent space-time, so it's going in a circle. You're welcome.
So neat. I saw that there's also a question about, is the moon slowly moving closer to the Earth? Actually, the moon is slowly, very slowly moving away from the Earth. All right. So
We
while
have
we
a
look
few more
at,
constellation requests as well.
yes.
Capricorn and Scorpio. Now, Scorpio is
Yes.
later in the summer, but
Yeah, so Scorpio is the one that we can see. It's mainly known as more of a summer constellation. So Orion was a winter constellation. Scorpio is actually on the opposite side of the sky, so it's a summer constellation. However, because we're in the spring, we could see it, but you have to be up really, really late, or in other words, really early in the morning. So let's take a look over towards the south area so we can see constellations set and rise. And let's see if we can fast forward through time. Will you let me? There we go.
and
So
I see Linda had answered that question as well. Thank you, Linda.
thank you very much, Linda.
It's so good to have you here.
So good. This is taking me a while. The program is very, very slow, but
Well,
I will eventually get there.
while you're getting there, Tessa is asking, what would happen to the Earth if we didn't have a moon? So I know one thing for sure is we wouldn't have tides anymore. I mean, maybe a little bit because the sun also affects tides, but mainly we have tides because of the moon. And actually, even though the supermoon isn't that much closer, like it's like, you know, than even the micromoon, it does affect the tides somewhat. So we actually do get bigger tides during a supermoon. So we wouldn't have tides. That would definitely change things a lot.
All right, so I finally made it to where we can more or less see Scorpius fairly well. It's right before 3 a.m. And if we wait a little later, I don't know if we can just make Capricorn right before the sun rises. So this is 5 a.m., almost 5, and then almost 6. And as we can see, the sky is very bright. So can't really see constellations, stars, and planets at that point. But right before it gets bright, we can just make up Scorpius and Capricorn.
I'm noticing a common
Tomorrow
theme
morning.
here. I'm noticing a common theme here in the constellations that people are asking to see, and I think it's that these are zodiac signs, right? And again, that comes back to that difference between astrology and astronomy, but something that we relate to with astronomy is those zodiac signs. And Lucy, I know on this program you can kind of call up the line and sort of show that in the sky, which might be kind of fun.
Yeah, so the ecliptic line is the imaginary line where the sun is traveling along. So people have noticed very long time ago that as the Earth goes around the sun seems to go in front of certain constellations. And well, this is the line where the sun would be traveling, and the constellations it goes in front of are known as the zodiac signs. Depending where the sun was a few thousand years ago, when you were born, that was your sun sign, your zodiac sign. What's really neat is that tomorrow morning at 5 a.m., we'll get to see Saturn in Capricorn and Jupiter right here in Aquarius. So if you're an early riser, you'll get to see these constellations. All right. Now, let's see. I'll try to get closer to where we're at now. Here we are. So that I wanted to show a few people, well, you guys, a few more things. Let's take away the ecliptic line, however.
So we have a question. This one, Linda, I don't know if you've got some answers for this too, but why the moon is actually moving away from the Earth a little bit. Now, I know it has to do with the tides again, and the tidal bulge that gets a little bit off from the moon, so it's sort of, I think it follows the moon a bit. I'm not, somebody correct me if I'm wrong here, but anyways, it's off a little bit, but though that sort of, okay, somehow the energy from the tides gets translated to the moon, but I'm not really sure how that works. I'm frantically Googling. I'm like, I know it has to do with the tides. So anyone in the chat, chime in if you're here. And as Lucy continues, I'll keep searching in the background, but something to do with the tides and sort of transfer of energy. So some energy is getting sort of shifted back to the moon. I'm like, how?
Yeah, I was wondering the same thing because I knew that it was moving away, but I just couldn't recall exactly why and didn't feel comfortable trying to explain that. But good luck with the Googling.
Yeah,
I do a
and
bit
this
of.
is what I love about this is like it keeps me on my toes. Like I keep learning every time we do a star party. So it's very cool.
Exactly. While you're doing that, I'm gonna show a few more constellations. So again, we're gonna go back to the Big Dipper or Ursa Major, the Big Bear, and it's the really long tail, if we remember correctly, right over here. And well, from here, we can do another kind of star hopping. Instead of taking the two stars, the pointer stars from the pot that goes to the North Star or Polaris, we can take the handle of the Big Dipper and arc over here to this really bright star called Arcturus. Good trick to remember, Arcturus. It is part of a constellation known as Bootes. It's a herdsman. And from here, there's another little jump we can make. After arcing to Arcturus, we spike over to Spica, which is part of Virgo the Maiden, which is where the moon is currently located. The moon, the planets, the sun, they all travel. Well, the sun is exactly on the ecliptic line, but the moon and the planets also travel along that line because the planets, the major planets, we're all pretty much found on this one plane orbiting around the sun. So we're all fairly traveling along the ecliptic line. And that means that if you're trying to find any of the planets, you'll get to find them in the zodiac signs. So, for example, Mars is right over here in between Taurus and Gemini, the twins. And then from Virgo, we can find this other neat constellation. If we take the lines and arc away, we can see that there's this kind of like upside down question mark or reverse question mark with a triangle here. This makes Leo the lion, and he happens to be found underneath the Big Bear, Ursa Major. And there's happens to be also a Leo minor. There's this other zodiac sign, Cancer the crab, but this one's much harder to find. It doesn't have any bright stars. It happens to be my zodiac sign, but I usually can't find it. I have to find Gemini and Leo and know that it's pretty much in between the two. All right, Aletha, do we have any other questions or did you find a good answer? You're on mute.
Again, I don't want to overwhelm with typing clicky click noises. So I see someone's linked the BBC.com article that I found too, but I'm just like going back to my basic understanding of physics, and I'm like, there's nothing, energies, the way energy is transferred. I don't get it yet. I'm going to look into it. Maybe this is a topic for next week. We can kind of bring it in. I know actually I did promise to show you guys the Hertzsprung Russell diagram because it came up last week about there being different types of stars. So maybe towards the end, we are getting close to the end of our time. I can show you the Hertzsprung Russell diagram of all the different stars. We do have a question about if we have favorite constellations. So how about you, Lucy? Do you have a favorite constellation?
I actually do. And for anyone that was here last time, I did mention it. In between the Big Bear and Little Bear, the Big Dipper and the Little Dipper, we have the tail, body, and head of Draco the Dragon. That happens to be my favorite one. And it's also a fun one to find because once you find the two bears or the two dippers, you can then star hop and find Draco. How about you, Aletha?
Well, mine is Scorpio, but not because I'm born the end of October. So I guess I would be Scorpio, but then I've also learned that because of the precession of the Earth, I was actually born when Libra was behind the sun, not Scorpio, because it's astrology it's an old belief system, I guess we'd call it. But the reason I like Scorpio is because in the summertime, in August, when usually the first week of August, I get to go camping for a week. And when I look out over Lake Huron, I get to see the galactic center, and I get to see Scorpio's tail kind of pointing at the galactic center. And I enjoy that immensely.
I absolutely love Scorpio also. There's another thing I absolutely love about Scorpio is the fact that one of the brightest stars in there, it is a reddish star, a red supergiant star known as Antares, which literally means not Mars. Because of the reddish color, people would mistake it for Mars, and Mars does go through the zodiac sign, so it's very easy to mistake it. So they decide to call it not Mars, Antares, which is wonderful.
Well, and that segues nicely into the Hertzsprung Russell diagram, because we just mentioned that red giant. So I actually do have the Hertzsprung Russell diagram here that we can share with you. And what this diagram does is it sort of maps out or lays out in a graph. Renata, if you wouldn't mind bringing it up, that would be great. Yes, thank you. Oh, there it is. We're making you work. So on the x-axis here, we have temperature. Sorry, my caption says in degrees. At these temperatures, Kelvin and Celsius aren't much different, but we're probably talking Kelvin because that's what astronomers use. So you can see our sun here has a surface temperature, because this came up last week as well, the surface temperature of the sun. I was all excited. Oh, it's 5,000 degrees, and actually closer to 5,400, and that's just the surface, or 5,500. That's the surface. Because when I heard that number, I'm like, that doesn't actually seem that hot. Like, isn't nuclear fusion going on in there? And yes, and at the center, it's more like 15 million degrees Celsius. So very hot. But what we're looking at here is surface temperatures. And so you can see that there are all different kinds of stars. And when you look up in the night sky, you can actually make out these different types of stars. Orion is a great example of a constellation that has a blue star and a red star in it. And maybe we can show those after. And then you can see we have these red giants. So the redder the star is, the cooler it is, the more blue it is, the hotter it is. And then, of course, they get brighter as they get bigger. So those are the different types of stars. All right, back to Lucy. Maybe we can sort of wrap up with Orion, and I'll just check if we do have a couple more
questions. Wonderful. Stars are so neat, but yes, bluer color is much hotter than the red, and depending, some stars are much bigger than others, so that all comes into effect to pretty much show like there's some stars that are going to be much brighter than some, and also depending how far it is from us. So it really depends on a few different aspects of that'll play with how bright a star would look to us, and what color it would be having to do with its surface temperature. Now we are looking at Orion. We have Betelgeuse, which is nice and reddish color, while, for example, Rigel is a blue color, and it is a very massive star, much bigger than the sun. So you said there were more questions. Was there any that we can answer real quick before we logged off?
Yes, we did. So we did get a question about like what if the sun disappeared? What if the other stars disappeared? So a question about like, like on that scale. So if the sun disappeared, of course, that's the source of our energy and our heat, and we would not do very well without it. If all the other stars disappeared, I think it would have a big impact on us, because that's our galaxy, right? So that's basically would be our galaxy disappearing. And I'm sure that would change things for us. We have here a question sort of more zeroed in on, do other planets in our solar system have an important role to play with for the Earth? So is the Earth affected by the other planets in the solar system? And I don't really, I know there are gravitational interactions that sort of happen over long distances, like we think there might be a planet X because we see these perturbations in, the orbits of other planets. But I don't think they do have an interaction, not that I know of anyway. So
probably not a very major effect.
Yeah. And I've got somebody saying Scorpio rules.
Yes.
All right. And so the question I think that the Hertzsprung-Russell diagram brought up is, why are some stars brighter than others? Do you want to take that one, Lucy?
I think I just kind of covered it real quickly
Kind of
beforehand.
Yeah.
Yeah, where it depends on how far a star is, how big it is, and its temperature and whatnot. They'll have to do with how bright a star will be.
Right.
Yeah.
Yeah.
There's some really massive stars that are really far away that look brighter than some of the smaller stars that are closer. So it really depends.
And I guess it's an interesting question too, if it's not just size. Like you get a supergiant that's big, but it's still cool, and then you can get a red dwarf, you know, that's small. So it also, I guess, depends on the composition of the star, like what it's mainly burning. So most stars are mainly hydrogen, but through nuclear fusion, they're building those heavier atoms that everything in the world is made out of. So you are made of atoms that were formed inside the heart of a star. And so that's kind of a neat spot to end on.
Yeah. So yes, a lot of things goes in and how luminous a star will be. One thing we can show you is another link that we like to use. Clear Sky.
Oh yeah.
cleardarksky.com. If you go onto that page, it in fact just cleardarksky.com, there we go, leads to this page. And if you click on the clear sky charts, it comes to this page where you can find where you're located. I already have one up for where I'm at, Sudbury. So it shows the cloud cover, transparency, how the seeing would be. So if you kind of scroll down, it shows what each section means. And that way you can try to gauge and see if there's going to be a good night sky viewing.
Yes,
So
and maybe we
very
can
useful.
share the night sky tonight map again. So that's a free map you can download. Take it outside with you tonight and take a look for those objects that we looked at tonight in the night sky, or the constellations. See if you can pick out the red star and the blue star in Orion, maybe low on the horizon, and let us know next week what you found, because we are going to be back here next week, same time, 7 o'clock. And that's going to be May 1st. So that is actually Beltane. So we can explain a bit, that's a Gaelic celebration, and we can explain a bit why Beltane falls on May 1st. And of course, we'll do another night sky tour and answer all of your questions. So if you're interested, the link will be up come Monday on Eventbrite, and we would love to see all of you there again. Thank you so much for joining us for this virtual star party, and we are looking forward to them being in person as soon as it's safe for us to all gather together. Thanks. Bye.
Thank you, everyone. Bye.